So on the second part of the same paper, you guys are also gonna do another notice and wonder between these two graphs. And I'll give you guys about a minute to jot something down and we can share something after that 1 minute is over. I'm gonna be giving you guys a stamp. You guys have at least one notice for graph A or graph B. So it'll take about 30 seconds to share with your partner something that you guys noticed. I'm going to be calling on a table to share something out loud. So make sure you guys have something to share. So someone from Brian's group with something that you guys noticed for graph A. It's okay, graph B. Graph B has a U shape. So we have a U shape. What about graph A?
The 9 is going up. It's increasing.
It is increasing. Is there anything else you guys can tell me about the shape also?
The graph starts in a negative and increases to a positive.
Yeah. So since it's starting at a negative and it starts to increase slowly to a positive, it creates like an S shape, right? Someone said yesterday it looks like a chair. But it also has S shape. Do you guys notice anything different between the equations that might contribute to why the shapes are a little bit different?
The degree.
Yeah. So we're gonna be taking a look at that. So our degree here is 4, U shape. Our degree here is 3, and we have the S shape. So you guys are gonna be doing a group investigation, which is the second paper that I passed out during class. Well, where you guys are walking in. So in your groups, you guys are going to be doing a group activity. Each group has an equation on their table. It's a green piece of paper. So in your groups, you guys are going to have a timekeeper, someone that's going to check in with their group, because you guys are only going to have 15 minutes, and that's it. The recorder, writing on the poster, the facilitator, making sure the conversations stay within what we're doing, and the task manager. They'll keep everyone on task, but they're also going to grab a Chromebook to graph the equation on Desmos. So take about 30 seconds so you guys can figure out who's doing what. So that way we can stay organized. also be presenter. We're going to be presenting our graphs. Okay, so what I want to see on your guys' activity, I want to see the equation at the very top. I want to see an XY table with at least 6 points. I want negative, your 0, and your 2 positive points. And I want to see a sketch of your graph. It doesn't have to be perfect, but I do want to see the shape, whatever shape it is that you guys get. And the task manager is in charge of graphing it on decimals. So Mr. Esquivel passed out a piece of paper. This is kind of how I want it to look. Or you guys have another example over here in the corner on how it should look. Because we're going to be comparing graphs at the very end. So go ahead and grab your laptop and start graphing on decimals. Whoever is task manager in each group. Your 15 minutes start now, so you guys are not gonna get extra time. Just someone go get a rock, paper, scissors.
Why are you switching up? It's one of those things that you just have to forget.
You guys only have 15 minutes. And that's it.
Do we have to explain?
You will.
Fourth degree, right? It's 4th degree.
So there's an example. So you're gonna put the equation, a graph, and a table. You can get all of that from decimal. So type in the equation on decimal, and then I'll teach you how to get the table. So who's gonna be the one on decimal?
So it would be, well, degree of 4 will be equal to my graph B.
This one's gonna look different.
Not
You guys have to investigate.
makes sense. That makes sense. Doesn't make sense. Let's discuss further about it.
How do I put the point?
Yeah, that's how you do it. You just take this
degree, it has to be.
Oh,
There's no correction.
So I see most of us are already on Desmo, so we're gonna show you guys a shortcut on how to get your table.
what the hell?
So that everyone's here already? At least on Desmo? We're going to click this little gear at the very top.
Oh, there.
After that, you guys are gonna click on create table. You guys are going to click on create table and it's gonna give you all your values already. So you guys can just copy this down on your poster paper and then just sketch your graph. Sketch just literally means your x-intercepts, your y-intercept, and then the shape of the graph. Any questions?
Zero, right? The vertical intersection.
Okay, you guys have about 8 more minutes. Yeah.
The vertical intercept is the y-axis. So it's zero.
Guessing?
And the horizontal intercept is what?
It's 2.
Did you guys fill everything else out?
I did more.
No. Well, what's your group name? What's your group? None of those. Okay, so put none.
Let me see what you had.
Yeah.
First day.
So, yeah. So go ahead and click the little gear on top, the little circle, and click that table emoji, and it gives you your table. So all you have to do is write down your x and y values on the paper. There's markers right there because I need everybody to see from the front of the class. And then you guys can sketch your graph and write your equation at the very top. Good? Productive. Oh, I see the paper all the way over here. That one. They're gonna be perfect. Do you guys have markers?
Who's presenting it?
Yes, the recorder is the one that's going to be writing the paper. So who's the recorder?
I see you.
Hi. Okay, so let's stay on task. Let's write our equation at the very top. Did you end up graphing the graph?
No.
Yeah. So we're gonna put the graph into Desmos. You guys have about 6 minutes left, so let's make sure that we're on task. We're going to be presenting it in front of the classroom right now.
What is this one? I think it's apple or something.
crosses because someone else must have done it. So crosses, figure out where your cross is. So you guys can get your vertical first step. And then for your horizontal, check where your crosses and your crosses. So yeah, she grabbed it for you guys, and then go ahead and fill everything out on your guys' page. You need the table, you need the graph, a sketch of the graph, and you need your equation. So you need 3 things on your paper. It doesn't have to be a perfect graph. I just want to see the shape. There's one right there. You guys have about 4 minutes. 4 minutes.
We need to put whatever right there. We put the x, the y, and the degree in the bottom right here. So like yeah.
Please don't look for
Don't put percentage, just put like odd over there here, or so other odd between goes over there. But you guys know what it is.
You guys have 4 minutes left. At least just sketch the graph and put the. Wow, you guys, this is so fancy.
Their graph? Are they showing their work or no?
No, you don't have to show your work. You can actually figure that out by going on Desmos too. I don't know. So your x-intercept's going to be here, and your y-intercept's going to be here too. Because I don't know, you don't see it crossing any other time, right? It just crosses once, right through the middle. So it's gonna be 0. You guys have about 3 minutes left. And don't forget your equipment.
But you said we just put it right. We did do the market.
And then write your equation somewhere big.
Big, like you got all the space.
The numbers are blue.
That's what I'm doing.
Look what I took.
Where did you go?
Oh, we're looking at a group name.
What's what?
I really like Kiss My Exes.
Alright, so less than 2 minutes, so make sure you have the equation, the graph, and the table. And start selecting who's gonna come up.
How do we do the graph?
Like what number is it?
Oh, so she went over it on the how to get the table. You guys weren't paying attention? I know she was in the restroom, but.
I was.
Alright, so click on that circle right there on the decimals. Then click on the table thing right there. There you go, you got the answers.
I don't like the equations.
There's an equation here.
I want to see the equation on the table.
Like a half.
Bro, this is
Right here.
You guys have 30 seconds.
There's no good ones. Wait, we're gonna put that there.
Okay, so time is up. Did everyone get a chance to do the degree on their piece of paper? Again? No? So if your degree is 1, 3, 5, 7, put it on the side. Send someone and bring your paper and put it on the side.
Degree 4, right?
If your degree is 2, 4, 6, 8, put it on the side. If your degree is 3, just put it on the side. You don't have to write it on your paper. If you have degree 2, 4, 6,
Write this down
8,
really
it's
quick.
going to be on this side.
It's 2. Closer, need to come up. So I see some beautiful graphs. We're gonna go ahead and take a look at the ones that had 1, 3, 5, 7 as your degree. We're gonna take a look at this one. And we're gonna take a look at that one over here. Do you guys notice anything different between these two graphs right here? Just the graph, the picture.
One of them was increase,
And the other one?
is decrease.
Yeah. So this one starts from the bottom. As we're moving to the right, it starts to go up to positive infinity. So this graph is increasing. This graph, like Anthony said, it's decreasing. As you move to the right, it starts to go down to negative infinity. What is causing that shift to change? What's causing the direction to change in our graph?
The other graph has negatives and the other one has positives.
Yeah. So the only thing different is that this graph right here has a positive sign in front of everything, and this one has a negative sign. And do you guys notice anything from the numbers in our degree? This one has 3, this one has 5, this one has 5, this one also has 3. What's the common trend between each number? What are those numbers called? Yeah. So if your degree has an odd number as the highest degree, it's going to be an odd polynomial. And the same thing with this one over here. Since they're all even, what type of polynomial am I gonna have here? We're gonna have an even polynomial. So these are both positive. So what would my graph look like if I wanted to do this one negative? It would look upside down. It would still cross at 0, 0, but my y-intercept would switch. So instead of it being at negative 2, 4, instead of it being at negative 2, 4, it's going to be,
Positive? Wait.
yes, negative 2 and 4. That is 4. So it's going to look like this. And what would my equation look like if my graph looked like this? Yeah. It would be negative x and what follows after. X plus
X
4.
plus 4.
Yeah. Or x, yeah, x plus 4. So that's the only difference between it having a negative sign and a positive sign on this side. Do you have any questions?
No.
Okay, so we're gonna pass out a packet of paper. We're gonna take notes. And then you guys are going to have an exit step. You guys don't need your computers anymore. So on our first page, we're gonna write the definition of an odd polynomial. So when a polynomial has a degree of 1, 3, 5, 7, 9, and so on, it's considered, yes. I'll give you a pen. It's considered odd. This one? So there's different ways that our odd polynomials can look like, depending on what we're adding, how many x's we have. But what's one thing that you guys notice from B and C? Go ahead and take about 30 seconds to find something, write it down, and then we'll come back and share together. Okay, so someone from Flor's group, what's something that you guys noticed from BNC?
I noticed that they're the same graphs, but just that C is negative.
Yes. So we noticed that B and C are the same graphs, but there's only a negative sign that affects the way that our end behavior is going to be, right? So our end behavior here is increasing. Our end behavior for C is decreasing. So you guys can write that on the side over here. Increasing end behavior. And this side is decreasing end behavior. Jacob, the end behavior with an odd function changes when what? What is something different between E and C that could influence the end behavior of our graph? Yeah. So it changes when there is a negative or positive sign. So our end behaviors change when there is a negative or positive sign in front of our equation. So at the bottom of the paper, there's an example. I want you guys to answer whether this graph is odd. If it is, why? If it's not, why not? I want you guys to find the degree, the leading coefficient, your x and y intercepts. And then we'll skip the expanding for now. So you guys have like about 2 minutes to go ahead and break down. I'll give you guys 3 minutes. If you guys need help, raise your hand or consult with your group. But other than that, you guys have 3 minutes, and I'll be walking around to see if you guys need any help. And before we get started, do you guys have any questions? We're good? So what do you think is it odd or even? Do you think it's odd or it's even? It's even? Why do you think it's even? You're just okay. What about this group? Do you think it's odd or it's even? Odd? Can you improve that? Yes. How are we doing over here? We're not gonna do that part. It's gonna take you guys so much. Let's go. That's the whole time. This one, this one, this one. What do you guys think? Is it odd or even? So if it was 4, it would be 5. What do you think the degrees? I mean, is it odd?
wise words from Jacob.
So she just did it. She said 7. She said,
I mean, the definition was up there too. You guys put it.
you did it on the board.
Okay, so now both of us are done. So what's the degree of this polynomial? It's 3. We're counting how many x's. We have 3 x's. What's the leading coefficient? Our leading coefficient? 1. Why is it 1? If we multiply our x's out, it gives us x to the power of 3. There's no number in front of it. So when there's no number, we have an invisible 1 right here. What's our y-intercept? It is -2. We get -2 by multiplying 2 times -1 times 1. And we get -2. What about our x-intercepts? Yeah, so -2, 1, and -1. How do we get those numbers? Yeah, so we take each one of these and we equal them to 0. So we know that we're gonna have 3 solutions. And is this graph odd? Why or why not? Why is it odd? Yeah. So even though this looks like an even function, graphs can be deceiving. What we're gonna look at is the highest degree. So if a highest degree is an odd number, it's going to be an odd function or an odd polynomial. Any questions? Okay, so go ahead and turn your paper to this part. It's the second paper. The definition for an even polynomial is at the very top. You guys can copy that down so you guys can refer back to your notes. When a polynomial has a degree of 2, 4, 6, 8, 10, and every even number after that, it's considered an even polynomial. So we're gonna do the same thing we did for our odd polynomials. I'll give you guys about 30 seconds to a minute to do. I noticed the graph B and C are wet, and the end behavior with an even function changes when wet. So I'll give you guys about 40 seconds. I'm gonna go around, give you guys a stamp. You guys are gonna be turning in 2 things today.
What does this mean?
What is something that's making these 2 change in our equations?
Oh.
Yasmin's group, is there something that you guys noticed from graph B and C?
It's the same graph the C and
Yeah. So B and C are the same graph. This one is negative, this one is positive. But graph B is facing up. And graph C is facing down. When you guys go on to pre-calc and calculus, it's going to be called concave up and concave down. It's just fancy way of saying our graph B is facing up and graph C is facing down. And so the end behavior changes with an even function when what? Yeah, in the genesis. When it becomes a negative. When there's a negative, when there's a negative in front, it's going to change the direction of our graph. So the second part is also another example. It's example number 2. I want you guys to take about another 2 minutes to complete that example. And then we're gonna go over whether it's even, why or why not. And if you guys have any questions, go ahead and raise your hands, or you guys can talk to your group members.
I told you.
How many x squares do you have? And when you multiply them together.
I told you. Oh my god. Oh, the only right thing I said. What's your degree?
For what? No.
What about the big one?
You don't know what
It should be like one.
For what? You didn't accomplish it?
Or is it a
So 2 times -1
Oh,
gives you what?
big this way?
For the y intercept, yeah.
Okay.
Oh wait, no. This is together and this is together for the y intercept.
It should be negative one. Negative one.
So then what is yes,
Or
yeah. So if this turns into a positive, this turns into a positive, and the positive turns into negative, gives you the same.
Oh yeah.
Okay, I see that most of us are done. So what's our degree for example number 2? What was it? 4. I know the graph sometimes looks funky, and when you're in doubt of the graph and you have your equation, all you need to do is count your x's. But since there's a 2 attached to our x, it's going to be x squared times x squared, which gives us x to the power of 4. So what's our leading coefficient? It's going to be -1. There's an invisible 1 right here, but we can't forget that we have a negative number in the front. Another invisible -1. So -1 times 1 is -1. What about our y-intercept? It's going to be -4. So the way we get -4, there's an invisible -1 here. We have a 2 here, but there's a square attached. So we're gonna do 2 squared times -1 squared. This stays the same. 2 to the power of 2 is just 4. -1 to the power of 2 is -1 times -1, so it gives you 1. So 4 times 1 is 4. 4 times -1 is -4. What about our x-intercepts? Yeah, so it's -2 and +1 for our x-intercepts. And is this graph even? Why or why not? Why is it even? So it is even because our degree is an even number. And what about our end behavior? Is it increasing, decreasing? Is it doing both? So it does increase here, it decreases, and then it increases again and goes back down. But what we notice is that it stays below our x-axis. So all of our numbers are always going to be negative. So it's facing down, and the end behaviors are going to be going down. So all the values are going to be negative for this graph. So you guys are going to be getting an exit slip.
Yeah.
So I want you guys to clear your desk, no notes, no phones, computers. It's going to be over the exact same thing that we just went over. You'll turn it in with your no, the package? Yeah. So the only thing you guys are going to turn in with your exit slip is this page and your group activity.
Not the next.